Welcome to Intro to Programming. This is part 7, loops. All right, let's get into it. Loops are used to repeat a block of code multiple times. There are two different types of loops in Python, while loops and for loops. We'll look at for loops first. One note, if you want to stop a loop in a running program, let's say if you have an infinite loop, and we'll get to those in just a minute, and you need to break out of it, you just press Control C in a running program and it will force stop the program. All right, for loops. So a for loop is used to iterate over a sequence, such as a list, tuple, or string, or other range. This first loop will print numbers 1 through 100 as it iterates through the range. I'm going to do, let's see here, that. Make it easier to read in the future. All right, so let's take a look at this first loop. And there we go. Okay, so these first two loops here. So for I in range 1 through 101, print I. So, okay, so let's go through this part by part. So this is just saying what kind of loop it is. It's a for loop. So for I, this can be any variable name that you want. This is just a variable that gets used in this loop to run the loop. So for I in range, so we can use a particular range if we want to define just some numbers. This is from 1 to 101, but if you recall when we were doing lists and getting a slice of the list, we would always have to do one more on the end than we would do normally. So if we want to get 100, in this case, we have to put 101 because it will only go up to one less than the range being defined. So, and then all we do is say print I. So let's comment this one out actually, and let's run it. And there you go. You can see it printed our list, and it just prints the numbers from 1 to 100. So another thing you can do is if you have a string, you could say for letter, and again, this is just the name of a variable. This could be any name we want it to be. So for letter in hello, print letter. And what do you think is going to happen when we do that? It prints the word hello, but it prints it vertically because it's printing one variable, or I'm sorry, one character at a time, and then it prints the one character, and then it loops back up to the top, and it runs the program again until it's at the end of the character, or end of the string. So that's kind of for loops. They're pretty easy to understand. They're for ranges and for printing over lists and things like that. So while loops will iterate over a block of code as long as the condition is true. So let's take a look at this. Okay, so we set a variable x to be equal to 0, and we say while x is less than or equal to 10, print x. And then x plus equals 1 is the same thing as writing x equals x plus 1. Or x is assigned to the value of x plus 1. So let's take a look at this. So yeah, we've got our variable declaration. That's easy to understand. While loop. This is also easy to understand. While x is less than or greater than 10, print x. So you'll notice we could accomplish the same thing with a for loop in this case. We could say for I, or if we wanted to use x, we could say for x in range 1 to 11, print x, and then we wouldn't need the x over 1. But this is just to show that the while loop runs as long as the condition is true. As soon as it gets to when x becomes 11, this while loop will stop running and it will move on to the next part of the code. So let's go ahead and run that so you can see that. All right, there we go. We printed from 0 to 10 because we set x to be 0. And yeah, that's how that goes. So the thing with while loops, and any kind of loop, but it's easier to see in a while loop. It'll keep printing this number 1, until the condition is false, which in this case is never. So we're just saying while true is true, print 1. So there's no exit condition. There's no, it's just gonna print. So let's do that real quick. Whoops. And run. And you can see it's still running. It's just printing 1 over and over and over again. So if you remember up here, to force stop a loop, we're going to press Control C, and there we go. You'll see this message pop up and the keyboard interrupt. That's what we did to stop the program. Another for loop that you might, or another infinite loop that you might see is, let's say you have for I, and actually let's say while x is less than or equal to 10, just like this other program or other loop up there, we're going to print x, and then here, let's go ahead and comment that out. But let's say we set the value of x to be equal to 11. And then we say x plus equals 1. So when we do this, if we save it, and run it, let's see. Okay. Oh, right. This automatically stops, but what you could do is say, if you had a, there we go. If you could say while x is not equal to 10, print x. Well, this will never equal 10 because we're starting from 11, and it just goes up and up. Because, yeah, this will never, ever equal 10. So just be careful with your variable declarations and things like that. Let's go ahead and do that. Okay, Let's take a look at the Fibonacci sequence. This is one thing you can do with loops, and we're going to show a little something neat you can do with, whoops, there we go. Okay. All right, so we're going to import time. The reason we're going to import time, you'll see down here. We'll go over that in a second here. So this is a way of defining variables. You're defining variable A and B concurrently at the same time. And then you're assigning it the values that you list one at a time. So this is essentially saying A is equal to 0, B is equal to 1. So they're assigned simultaneously. And then this is going to be an infinite loop, where it's just going to stop when we tell it to stop. So we're just going to say while true, print A. So in this case, it's going to print 0 because A is equal to 0. And then we come down here and we assign A to the value of B and B to the value of A plus B. So this wouldn't work unless we assign them concurrently or simultaneously. We wouldn't be able to do this. So this is saying A is equal to B, but B is equal to the value of what A was and what B was. So in this case, it'll print 1. And then let's look down here. Time.sleep. This just causes your program to stop running for, in this case, it's a quarter of a second. And that'll make it a little easier for us to see the output. So let's go ahead and run this and see if you can guess what it will print. If you know the Fibonacci sequence, then you already know. But all right. So you can see the numbers are printing fast, but not as fast as they were before. All right, let's go ahead and close that or cancel that. Come on. Oh, I didn't have it in the right area. Okay, so the Fibonacci sequence, it starts with 0 and then 1, and then it combines the last two values, and that's the next value. So in this case, 1 plus 0 is 1, so we get 1 again. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5, and on and on and on and on. So that's the Fibonacci sequence. Let's go ahead and comment that out, and you can play around with that on your own if you'd like. Okay, and then one last thing to talk about with loops. Sometimes you want to have a loop running, and let's say you want it to be an infinite loop, but you do want it to break eventually. So what you could do is you could use an if statement, and this is kind of a poor example because we could just print from 0 or from 1 to 33. But let's say this, we want to use this as our example. So for I in range 1 to 101, so what is this going to print? It's going to print the value, or it's going to go through the values of 1 through 100 because we always add one more to the end of a range than we need. for that range to work. So we're going to print I again. So we're just going to print, we're just going to print the value of I. And then we have this if statement. So we say if I modulo 33 is equal to 0, then break. So this is essentially saying if I is equal to 33 or a multiple of 33, then we use break. So what break does is it stops the loop from running and it moves on to the next portion of code. So let's go ahead and run this. There we go. As expected, it ran numbers 1 through 33. This if statement became true, and then it went to break. So that is that. Let's talk about the assignment for this lesson. So this is FizzBuzz. This is a game that children sometimes play, and essentially you count 1 through 100, but on multiples of 3, you say fizz, on multiples of 5 you say buzz, and on multiples of 3 and 5 you say fizz buzz. That's where the program gets its name. So we're going to write a program that prints the numbers 1 through 100, but for multiples of 3, print fizz instead of the number, and for multiples of 5, print buzz. For numbers where multiples of both 3 and 5, which are multiples of both 3 and 5, print FizzBuzz. So, a few things you're going to need. You're going to need a loop to run from numbers 1 through 100. You'll need the modulo operator. This is how you'll tell if a number is a multiple of 3 or 5. So this divides a number by another and returns the remainder. So 25 modulo 5 will return 0 because 5 goes into 25 evenly. And then you'll need print statements, of course, but that wasn't, I didn't put that in there. So that's what you're going to need for that. Let's go over the assignment from last week. And let's just take a look at the requirements real quick. So we wanted to, whoops, I didn't mean to do that. There we go. So this was going to expand your rock, paper, scissors code and make it so users can play multiple rounds without having to run the script a second time. So go ahead and copy your code in part 1 below and turn it into a function. So that's what the requirements were. Let's go ahead and look at, so this was part 1. All right, so we combined all of our if statements to be in just these 3 if and elif statements. So let's take a look. We want to make this so we can run it multiple times. So let's look at iteration 3. So what you'll need to do is you'll need to put everything inside of a function. So in this case, we have a function that says define, and then the function is rock, paper, scissors. And then I have this user score and computer score here. You don't need to have had that, but we'll go over that in just a second here. And then remember down here, we need to run to call our program, or our function. So we say rock, paper, scissors, and then I have the values 0 and 0. because I want to start at 0. And then, okay, so let's just go through this real quick. These are the variables. These are the same thing that we had on this one. Same variables. And then we have the draw condition. So if user input is equal to computer choice, we're going to print draw. You chose this, the computer chose that. And then I wanted to print the how many times the user uh, and the computer won each match that they're playing over and over and over again. Okay, so and then I put an if statement that says, do you want to play again? And just you have an input. If the input is equal to y, then I don't know why I have this print here. We can get rid of that. And then if that's true, then we're going to run the function again. So we're calling rock paper scissors, but this time we're passing in the values user score and computer score. So user score is defined up here, and computer score. Those values don't change, but we want to pass them in so that they stay current whenever we run the code. Okay, let's look at the first condition. This is the win condition. So if user input is equal to rock and computer choice is equal to, and then okay, so this is all the win conditions. So you win. You chose this and the computer chose that. So then we want to add 1 to user score. So user score is plus equal to 1. Remember, this is the same as saying user score equals user score plus 1. It's just a shorthand for saying that. And then we're printing our scores, so user and computer score. And then we have our if statement down here. Do you want to play again? Yes or no? If input is equal to y. Again, we don't need this print statement. Don't know why it's there. And there's another one down here. Can get rid of that. Then we're going to run the function again. User score, computer score. Okay. So, and then we have our final condition. Same sort of thing, but in this case, we're increasing computer score by 1 because this is if you lose and computer wins. User score is equal to 1, or computer score is plus equal 1. And then we have our if statement. If input, do you want to play again? Yes or no? Okay, so this is good, and this would get you through the assignment. One more thing you might consider doing is abstracting the code for if do you want to play again, because we're repeating the same code 3 times. So whenever you are repeating code, it's a good idea to put it into a function. So we have everything is the same except for this little bit at the end here. We'll talk about that in a second. But we have everything. So we have these 3 lines of code in a function. So this function is called play again, and we're going to take in the arguments user score and computer score, and those are passed. So we're essentially saying, let's take a look at the draw condition. We're saying if all that's true, then instead of going through the if statement and asking, we can just put, so this takes 3 lines of code and puts it down to 1 line of code. So we're just saying play again, and then we're adding the user score and the computer score. And then play again just comes down here, runs through these lines of code, and then it continues on in the program. In this case, it prints rock, paper, scissors, or it runs the rock, paper, scissors function again. So I hope that makes sense. We kind of ran through that kind of quick. But yeah, there we go. And then let's just talk about this a little bit here. We have another elif statement. If your user input is equal to close, then we're going to quit the program. So, and then I have an else statement here. Print, please type either rock, paper, or scissors to play or close to close. So this will force the user to type rock, paper, scissor, or close in the thing in order for the program to progress. So that might be something you'd want to consider. It's definitely one way of making software a little bit more locked down, so you eliminate some of the variables that the user could put in. So yeah, that is my completed code for rock, paper, scissors. If yours was similar, great. If you ran into difficulty, please let me know and we will go over it. All right, that's going to do it for this lesson. I hope you have a good one, and I'll see you in the next one. Bye now.